Hi, my name is Cody Stevens. I'm a member of the HPC team at Wake Forest University. Today I will be talking to you about high-performance computing on Wake's DEAC Cluster and giving an example workflow. Let's begin with a quick overview. So what do I mean when I say high-performance computing? High-performance computing, or supercomputing as it's commonly called, is a collection of computer systems configured to work together in order to solve large, complex, and/or parallel problems. So when do you use HPC? Let's say that you're trying to run a script or software and find it takes too long to run, or that you can't work on anything else while it's running, then HPC could be a good solution for you. Or, if you have to run the same script hundreds or perhaps thousands of times to gather all the data you need, HPC could be a good fit for you. Lastly, if you want to be able to log out of your computer or not worry about any reboots occurring while your script is running, HPC could definitely help you. If you find yourself falling under any of those categories, how can you go about using HPC at Wake? You could use our cluster. It's called the Distributed Environment for Academic Computing, or DEAC for short. It was actually established in 2002 by the physics department. Over time, though, more departments starting to use it. Eventually, the cluster became a centrally funded resource managed by Information Systems. This makes it a free resource to all Wake Forest Reynolda campus faculty and students, and the DEAC Cluster now supports 13 departments in total across the university. So what does the cluster look like? Here's a general overview of the DEAC Cluster architecture. It's broken down into three main components: user access on the left, support services in the middle, and compute nodes on the right. User access is through what are called head nodes. These are the only outward-facing systems on a cluster which a user can use to log into or transfer data in and out of the cluster. When logged into a head node, this is where users can submit their scripts or software to run as jobs on the cluster's compute resources. You also see archive storage shown, which on the DEAC cluster is a data storage environment located remotely in the cloud. Support services are vital to the cluster's operation and act as a gateway between the users and the cluster's compute resources. The DEAC cluster has dedicated research storage for its users. This storage is mounted by all cluster components, which is to say that it ensures the user's data, code, and required software are available on any compute node a job may run on. Support servers are hosts to functions that must be up and running for the cluster to operate. The best example of this is our resource management server. The logo there is for our resource management service, Slurm. The Slurm server communicates with a client installed on our cluster head nodes to allow users' jobs to be submitted and on cluster compute nodes, to ensure those jobs are evenly and fairly distributed across all available resources. Without Slurm, there's essentially no cluster. Another lesser example would be our license server, which hosts licenses that must be checked out and back in for certain software to run within a user's job. Compute nodes are the horsepower within a cluster. They contain all of the consumable resources on a cluster, like CPU cores, memory, or GPUs, that users can request to run their jobs on. The resources on the compute nodes are what Slurm keeps track of amongst all other user jobs running. It's our goal to ensure these resources are always available and at high utilization rate. Having seen the architecture, let's break down some of the available resources. The DEAC cluster is hosted at 95 compute nodes, which contain a total of 3,900 CPU cores and 20 terabytes of memory for users to consume. In comparison, your average Wake Forest laptop will contain 2 CPU cores and 8 gigabytes of memory, so it's similar to having 1,900 laptops at your fingertips, only these would be much faster and more efficiently configured laptops. The shared storage mentioned earlier totals 180 terabytes. This is used to store active research results and datasets and is backed up weekly to the cloud. Those cloud backups should not be confused with our cloud archive, which has an unlimited capacity. So we ask that researchers move older inactive data they wish to keep there. This keeps our higher tier storage available for researchers. Usage on the cluster, as mentioned earlier, is spread across 13 departments at Wake Forest University. For each department, the HPC team installs and updates required software as needed. You've heard mentioned that jobs are submitted to Slurm, which is done via batch submissions. Every cluster system runs on the Red Hat Enterprise Linux operating system. Knowing now the high-level operations of a cluster, it's time to go over the basics of workflow on the DEAC cluster for job submission. For this presentation, we will be using R as the basis for our example. Our workflow can be broken down into the following steps. First, we have to log into the cluster. Then we have to know how to use R both locally and on the cluster. We will then have to write our R code, and then we'll also have to develop a Slurm batch script so we can run our R code as a job. We'll then review how to submit our batch script as a job, and then once it's submitted, we will cover how to monitor our job. And lastly, we'll have to check for outputs. The basics of these 7 steps can be applied for this example job submission and any other job you wish to submit in the future. So let's go ahead and start with logging into the DEAC cluster. As was mentioned, the DEAC cluster is only accessible through its head nodes. Currently, there are 2 head nodes to choose from: pegasus.deac.wfu.edu or gemini.deac.wfu.edu. Our head nodes are only accessible from the campus networks to log in. This means your computer on campus must be connected to the WFU wireless network or a wired direct connection. If off campus, your computer must be logged into the Wake Forest University VPN using the Cisco AnyConnect client with your WFU account. The Cisco AnyConnect client can be downloaded from software.wfu.edu. Outside of these options, you will not be able to connect, which is primarily for security reasons. To access the DEAC cluster, users will need to use the Secure Shell Protocol, or SSH. SSH is a communication protocol commonly used for terminal connection, aka command line, or CLI for short. This means that from a Mac or Linux computer, you can use the built-in terminal of your operating system and type SSH space and then your username at one of our head nodes .deac.wfu.edu. Your username is your email address, but we're going to replace at wfu.edu with either at pegasus.deac.wfu.edu or at gemini.deac.wfu.edu. From a Windows operating system, however, an application must be used. The application that the HPC team recommends is Visual Studio Code Insiders. Visual Studio Code Insiders can be downloaded from the URL below. While we can access the DEAC cluster with the Mac/Linux terminal application, the next couple of slides are going to focus on Visual Studio Code because it's a powerful tool for editing files on the cluster as well, and it's recommended for users on both Windows and Mac platforms. When you open Visual Studio Code, you should see a window similar to this one, but yours may look a little different. If following along, pause the video now to ensure Visual Studio Code has been downloaded and is up and running. We're going to start by installing some extensions so that we can use Visual Studio Code to connect to the DEAC cluster and edit files once we're there. Start by clicking on the gear icon in the bottom left of the window and select Extensions from the menu that pops up. This will bring up a sidebar where we can search for and install extensions to enhance our installation of Visual Studio Code. We will want to install the highlighted packages. These packages are remote-WSL, remote-SSH, remote-SSH editing, remote development, and that's all. You do not need to install the remote containers or remote-SSH Explorer extensions, but you can install them if you want to. For each extension, click the small green Install button next to each extension's name. After installing the 4 aforementioned extensions, you should now see a small green button that has appeared in the bottom left corner of the Visual Studio Code window. To connect to the DEAC cluster, we're going to click that small green button, and that will cause a drop-down menu to appear in the top center of the window. We will want to select Remote SSH Connect to Host, the same option highlighted in this slide. Here you want to type your username at one of the head nodes and press Enter. I've gone ahead and typed my username, STEVCA9, at pegasus.deac.wfu.edu in this example, but you can also use gemini.deac.wfu.edu. Next, you will need to type your cluster password and press Enter. You will be prompted with a security question asking if you'd like to continue. When this happens, go ahead and select the Continue option. If you see that your green button in the bottom left corner has changed to read SSH: the head node you connected to, then congratulations, you're now logged in to the DEAC cluster. Now that we're logged into the DEAC cluster, next let's look how to use R. To use R on the DEAC cluster, you do not need to have it installed locally on your computer. That is because the DEAC cluster already has it installed. The HPC team does recommend, however, that you have R installed locally for basic script writing. The same R code that you write locally, regardless of operating system, will run on the DEAC cluster. If interested, follow either link provided to download and install R locally to your system. Additionally, RStudio is an available application that provides a nice and easy development environment for R. It can be downloaded and installed to your local system as well. Before we can look at the R version installed on the DEAC cluster, first we need to open a terminal through Visual Studio Code. To do this, start by clicking the purple button just to the right of the green button we used to initially connect to the DEAC cluster. This will toggle the terminal window to appear at the bottom of the screen. By default, your window may show Problems as opposed to Terminal. We will want to change our view over to Terminal. If you only see the options Problems and Output, click the ellipses and select Terminal. You should have a view similar to mine, except you should see username at the head node you connected to. Looking at the cluster's R installation, users must load it the same way as any other software installation on the DEAC cluster, with the use of an environment module. Environment modules load configurations to your current login session to make it as if those software packages were installed locally for your user account, when in reality, all software, including R, has been installed on our shared storage, which is how we easily make it available across all of our nodes. To load R's configuration, type module space load space RHEL7 /R 3.5.0 and hit enter. Typing a capital R is important because Linux is a case-sensitive operating system. A lowercase r will not work. To confirm that R is now a valid command, type which space capital R. You should see a path return to the R installation somewhere in /deac/opt/RHEL7 /R. There may be multiple versions of the software installed. To start, it is a good idea to check the loaded version, which should match what you typed with the environment module. Type capital R space -- version. The returning text should show version 3.5.0, nicknamed Joy in Playing, was loaded. To use R, simply type capital R and hit enter. The R environment should be loaded after doing so. This can be confirmed by the angle bracket or greater than symbol, now visible as a cursor on the terminal. To exit R, you can type Q, open parentheses, close parentheses, and hit enter. Moving on, let's get a quick sample R script going. Before we can start creating files on the DEAC cluster though, first we will want to change directories to one in our research path. When you first log into the DEAC cluster, you're initially placed in /home/your username, and we call this directory your home directory. We encourage users not to store large files in their home directory because there is relatively less storage available for our home directories, and if our home directories are full, then nobody can access the cluster. We can change which directory we're working in by clicking the Open Folder blue button on the left. If you do not see an Open Folder button, first click the Two Pages icon in the very upper right. Clicking Open Folder will once again bring up a drop-down menu. You may see /home/your username already there, which is the current directory you are in. We will want to delete that path entirely and start typing the path to your research directory. Your path should be /deac/business /analytics 2019 /your username. After you've typed in your path, go ahead and hit enter. You should now be able to see a list of files stored in this directory on the left-hand side. There should already be one file in this directory named tweets. When you move your mouse over the list of files, you should see 4 icons appear where your username is listed above the tweets file. We can create new files with the first icon, and we can also create new folders with the second icon. Let's go ahead and create a new file and name it R-example.r. If you have files stored locally on your laptop, you can transfer them to the DEAC cluster by dragging and dropping the file from your local Windows Explorer or Finder window to this list of files in Visual Studio Code, and vice versa. Here's a fully fleshed out, better look at our example code. You may have received a copy of this code from your professor. If not, you may want to pause the video to copy it down if need be. With our code now written, we can start developing our Slurm script. For this example, let's go ahead and create another file and name it example.slurm. Go ahead and copy the contents of the Slurm file on this slide to your newly created file, but make the following changes. Replace job name with something of your choosing. Replace your email with your actual @wsu.edu email address. And replace the directory path after the cd command to the path where your files are being transferred. This path is most likely /deac/business/analytics2019/your username. You may have already received a copy of this script from your professor. If not, you may want to pause the video to either copy it down now or update it if need be. This Slurm script is how we tell our scheduler Slurm how many resources we need to run our job, and Slurm will look at this file and use the information we provide it to find the right compute node for our job to run. I'll discuss these values in more detail in the coming slides. There are 4 primary resources we can request from Slurm. Those resources are nodes, CPUs, memory, and time. Each node has up to 44 CPU cores and up to 256 gigabytes of memory. So if we want our job to run on one node, then we should be sure to request less than 44 CPU cores and less than 256 gigabytes of memory. For this job though, we only need one CPU core. The code we've provided is a serial code, which means it doesn't need multiple CPU cores to run. We can request CPU cores through Slurm with the --n tasks per node option. Another important resource we can request from Slurm is time. Since Slurm is a scheduler, it has to know how long we're going to use the resources we request so that it can efficiently schedule other jobs around our job. If our job continues to run over the amount of time we request, then Slurm will end our job immediately, so it's always best to overestimate the amount of time you'll need for your job to run. We can request time with the --time option, and the format is days-hours:minutes:seconds. The last resource we can request from Slurm is memory, or RAM. Just like time, it's hard to guess how much memory our job will use, so it's always best to overestimate. We request memory from our job with the --mem option, and 1 GB will request 1 gigabyte of memory for our job. To encourage our users to request only the resources needed for their job to run, we've assigned priority to jobs based on partition. There are 3 partitions that you can submit your job to on the DEAC cluster, and those are named small, medium, and large. We classify small jobs as any job that can run on one node and can run for less than 1 day. Medium jobs may run on up to 8 nodes and must complete within less than a week. And finally, large jobs can request any number of nodes and time, but they must complete within 1 year. We also have a GPU partition, which is a specialized partition for jobs that require a GPU resource. Now that we have our Slurm script written, we're finally ready to submit our job. From our terminal session on the head node, ensure your current directory is the same as where you transferred your data, preferably in /deac/business/analytics2019/your username. This can be confirmed with the ls command, where you should see that the R code, Slurm script, and sample data are listed in your current directory. If present, the job can be submitted by typing sbatch /example.slurm. If successful, the result will return a unique job ID. If an error is returned, check to ensure syntax and case are correct first. Next, check to ensure the referenced R file within the Slurm script is correct. If still unsure, always feel free to ask the HPC team for help. Once the job has successfully been submitted, it can then be monitored. From the session where the job was submitted, 2 commands can be used to look at your job's progress. First is the sq command, which shows all jobs running or waiting to run on the DEAC cluster. To look specifically at your job submitted, type sq space -u space and then your username. If the job appears in the pending state, represented by a capital PD in the fifth column, the same command can be run again, but also with --start. That option will show the expected start time of your job if it's soon. The other command is SACCT, pronounced saccount, which you can also add -u space your username. This shows a list of all recent jobs running, pending, or completed. Once your job has finished running, it will no longer appear in the results of SQ. It will show the output of the saccount and will show as status completed. You should have also received an email thanks to the mail type directive in our Slurm script. Here's an example of a beginning email, which is sent when a job starts, along with the location of the job output file and the node that your job is running on. Here's an example of a completed email, which is sent when the job completes. It contains a summary of the used resources, time run, etc. Here are some other helpful Slurm commands you can run to get more information about the DEAC cluster. sinfo will show you more information about our nodes and tell you whether our nodes are idle, aka available for new jobs to run, allocated, or a mix between the two. Allocated nodes cannot be assigned new jobs, while mixed nodes can. We've already discussed SQ before, but at the bottom you will see a command slurm mem report. This is a custom command that you can add at the end of your Slurm file to get the total amount of memory consumed by your job while it ran. Once your job is completed, it's time to check the outputs. From your terminal session where the job was submitted, use the list command ls. You should now see 3 additional outputs: the script-generated error and output file, as well as the R script-generated output. If the output file is not present or contains unexpected output, then there's most likely a typo within your R script. Check syntax or the name and location of your CSV file. The content of your output file should look something like what is shown here. It can be transferred to your local machine as discussed earlier. You just need to drag and drop the file from Visual Studio Code to your desktop on your local machine. If your output looks good, then consider your job successfully submitted. And this concludes our presentation. Hopefully you found the content in this video helpful. If you need clarification or have follow-up questions or comments, please contact deac-help@wsu.edu. Be sure to also check out our other resources, including our website, user wiki, YouTube page, and to follow us on Twitter. And thanks for watching.